In this video, we're going to put together our little stars. So what I want to do is I want our stars to appear in our level, and then I want the player to be able to hit those stars and receive points. There's a couple interesting challenges that we're going to have to face, however, which is why I wanted to include this feature in this game. First of all, those stars I want them to create a particle effect when they're collected, and I want that particle effect to automatically destroy itself when it's done. That's a very handy thing to have laying around in your code base because creating one-off particle effects is a very common thing to do. In addition to that, this will also allow us to test our checkpoint system and how it resets our points if we were to die before getting to the next checkpoint. Finally, it'll also give us an opportunity to look at the concept of an object that should get reset when the player dies. There will be objects in this game that when the player dies and hasn't reached the next checkpoint, I want those objects to respawn. So we want the concept of an object that respawns. What I'll need to do is I'll need to generalize that into our level manager by allowing objects to listen to when a player dies so that they'll know if they need to respawn themselves or not. So let's go ahead and get started. The first thing that I'm going to do is I'm going to create a script. And that script is going to be responsible for adding the points and spawning a particular effect when that script is, well, when whatever condition that script wants to. So I'm going to jump into Visual Studio and I'm going to create a stub for our star. So I'm going to say create a new class and I'm going to call this a point star. I'm going to remove the namespace stuff from it, and then I'm going to have it inherit from mono behavior. Now again, I just want to stub this out. So what I'm going to do is I'm going to say public game object effect. The public game object effect will be a prefab that'll be instantiated when the star has been collected. Next up, I want to go ahead and say public int points to add, and I'll set this to a default of 10. That's all we're really going to need so far as public variables. We'll add some additional private variables later in this video when we implement this mono behavior in its entirety. But let's go ahead and write out our methods. So the method stubs that I want is going to be public void on trigger enter 2D collider 2D other. And so far, that's really all we'll need for our point star. Again, we'll be working on this class a little bit more later in this video. The next thing I'm going to do is I'm going to go ahead and write an auto-destroy particle system. The auto-destroy particle system script I will write in its entirety. And what we'll do is we'll place it onto a particle system object. And when that particle system object is finished playing its animation, then it'll die. Or not its animation, but its particle effect. So I'm going to create a new class called auto-destroy particle system. Hit enter, remove the namespace declaration, have it inherit from mono behavior, which of course brings in using Unity Engine. Then I'm going to say private particle system. Let's call this a particle system. And I'm going to say public void start. And then in my start method, I'm going to say particle system equals get component, as opposed to get components, particle system. That's all we're going to do in start. Now we need a public void update method. All the update method is going to do is say if particle system dot is playing return. Early exit out because we have nothing to do in that case. However, if the particle system is no longer playing, we want to destroy the entire game object that this script is attached to. Okay, so that's really all we have to do for an auto-destroy particle system. All it'll do is if we attach this to a particle system, the particle system will play its particle effect. Once it's done and it's no longer playing, that game object will be cleaned up in our scene. Alrighty, so now that we have enough of our code written, let's jump back into Unity. Again, I like to get the code written enough to where we can start working with these objects in Unity before they're fully implemented. So we can see how far we can get in Unity before we have to write any more code. Then once we're done placing these objects in Unity, we'll come back and we will finish the code up. So let's jump into Unity. What I'm going to go ahead and do is I'm going to do a couple of things. First of all, I want to create an effect. I want to create an effect prefab, and that effect prefab will be used by our point adder, and it'll be played when the point adder has been collected, or the star has been collected. So I'm going to say game object, create other particle system. So let's go ahead and create this particle system. What effect do we want to have happen when a player collects a star? In this case, I just want to do a basic explosion effect. However, for our code to work, for this to be auto-destroyed, we have to make sure that looping is set to off. If looping is not set to off, that means the particle system will continue to loop indefinitely and it'll always be playing. By setting is looping to false, then what we're doing is we're telling the particle system to play once and then die. All right? So let's go ahead and create just a really simple particle system. I'm going to set the duration to 2. I'm going to say the start lifetime is going to be 0.5 seconds. Let's set the start speed to 3. Let's start the start size to 2. Let's see what we're looking at so far. Okay, I mean, obviously that doesn't look like what we want yet, but let's go and jump into emission. For the emission, I want it to burst. I want this to be like kind of like an explosion burst, meaning I don't want it to continuously emit particles, so I'll set emission rate to 0. By setting emission rate to 0, nothing will be emitted, and our particle system will look like it's, well, not doing anything. But what I can do is add a burst. So what I'm going to do is I'm going to hit add, on this little button add, at time 0, so that the second the particle system starts, I want to create a burst of 50 particles. So as you see, we now have particles that are created, and then no additional particles are created after that. Next up, let's open our shape. I want this to be kind of like an explosion effect, so I'll set its shape to a sphere, and I'll set its radius down to 0.01. Let's see what we have right now. That actually looks starting to look pretty good. See how it kind of radiates out like that? That's pretty much...
That's coming along all right.
Yeah, it's pretty much exactly what we want. So now let's jump into our color over lifetime. For the color over lifetime, I'm going to go ahead and set our color at the start of the gradient to something like a yellowish color. Then I'm going to set the end opacity down to have it alpha of 0. And then I'm also going to leave the white there. So it kind of fades to white and it fades away at the same time. All right, I think that's looking pretty good. Now let's work on the size over lifetime. So the size over lifetime, we want it to start kind of biggish, and then we want it to curve down and get smaller. So let's go ahead and open up our curve editor, and I'm going to select this preset curve right here. You kind of see that it goes from 1 all the way down to 0. That looks pretty good. We can set that down a little bit lower and set that a little bit higher. And even that tiny little change made a really big impact on our... You know what? I think that looks pretty good. Now, obviously, I could sit here for the next hour and tweak this particle system. I love making particle systems. It's fun.
We've had this discussion.
Yes, I know. So let's go ahead and stop working with the particle system and do the last thing that we need to do, and that is add our component, our auto-destroy particle system component, which will result in this particle system, once it's created, it'll auto-play, and then once it's done, it'll be destroyed and cleaned up out of our hierarchy. Now that I've done that, all we have left to do is prefabify it, because again, this is going to be something that our point adder needs to reference. Our point adder needs to be aware of the existence of this prefab so that it can instantiate it. So I'm going to open up my prefabs folder, and I'm going to create a new subfolder inside of prefabs called effects. Then I'm going to grab this particle system, and I'm going to rename it, let's rename it yellow burst, because that's pretty much exactly what it is. This is yellow burst. Let's rename it small yellow burst, because it's small and it's a yellow burst. And then let's prefabify it into our effects folder. And now we have a small yellow burst in our effects folder as a prefab. All right, now that we've done that, I'm going to delete this, and let's put together our our star. The way that I'm going to make the star is I'm going to create a new game object. I'm going to create an empty game object, and I'm going to name this point star. And then I'm going to place this empty game object at the origin. Why am I doing that? Well, it's because the star texture, the star sprite that I'm going to be adding, I actually want it to be a child of the point star object, which the point star is going to be the actual prefab. Why? Well, the reason is so that when we go and animate it, we can animate the position of the child element without having the position of the parent element be set absolutely. But that comes into us animating it, which we'll talk about later. But either way, I want to orient this at the origin of our scene. Then I want to open up my textures folder, go into my texture atlas main, scroll all the way down and grab my star. Then I want to pull in my star and drop it right there. I want to translate it to 0, 0, 0, which is the origin of our scene. And then I want to child it to my point star empty game object. Now that I've done that, I want to go back to my parent point star, and I want to add, let's add a sphere collider to it, or circle collider, sorry. Let's add a circle collider 2D to our point star. And if we zoom in here, we see that it got pretty close, but we can do a little better than that. Let's move the center down a little bit, and then let's set the radius up a little bit. Well, maybe something like that. We have to compromise between accuracy and, well, playability as far as the player being able to hit the star, but we also want to make it simple so that it doesn't add a whole lot of overhead to Unity's collision system. Next up, on my star itself, the child element, I want to make sure that I set its sorting layer to foreground, because I think that's the most appropriate sorting layer for this particular kind of element. Now I want to go ahead and add the point star script to it. Let's leave points to add at 10, but let's go ahead and fill in the effect. To fill in the effect, all I have to do is go into my prefabs folder, my effects folder, and then click and drag small yellow burst onto my effect. Now I have a prefab associated to the effect parameter of our point star component. Now that I've done that, let's go ahead and turn point star into a prefab. So let's click and drag it and dump it right on our project. By doing that, we can now create as many of these point stars as we want, and any changes we make to our point star can be applied to all of our other point stars in the game world. Alrighty, let's go ahead and place our point stars in the world. Let's create a couple of them. I'm going to create one here. I'm going to create another there. I'm going to create some over here. All I'm doing is clicking and dragging and duplicating. Now, because I want to be able to have this be able to test our point system, I want to create a couple in between our checkpoints. And then my checkpoint 2. And then let's create a couple that I would have to jump in order to get, which will help us further test our checkpoint system. The point is that now I've created all of my point stars, or at least the ones that I want to add in this particular game, or in this particular level of this particular game. Alrighty, so if we were to play the game, absolutely nothing special would happen. Nothing special would really happen because we haven't actually written any logic into our point star component yet. So let's jump back into Visual Studio and implement as much as we can in our point star script so that we can jump on these stars, receive points, and then have them disappear, and then have the effect be played. So let's jump back into Visual Studio, and let's work on our onTriggerEnter method. On the onTriggerEnter method, I'm going to say if other.getComponent player is null, that means the thing that hit us was a player, or not a player, and that we want to early exit. Then I want to say GameManager.instance.addPoints, points to add. So this will add points to this particular object. Then I want to say instantiate effect, passing in our transform position and our transform rotation. What does this do? This will instantiate whatever prefab we placed into our effect property, or our effect field, and it will instantiate it and place it right at the location of where our point star is, with the right rotation of where our point star was. Now what I want to do is, let's go ahead and say something like GameObject.setActive false. Now, why are we doing setActive false? Why aren't we just destroying the game object? Well, remember how I said earlier that we want our point stars to be recreated if they are within a checkpoint that a player died in? Well, that means that I don't want to destroy the point star. All I want to do is make it no longer active. So I can simply say GameObject.setActive false. Now again, we will definitely be adding some additional logic into this class in this video, and we'll be adding even more logic on later when we work on our animations. But for now, this should be enough to test not only our addition of points, but also the instantiation of our effect. So let's come back into Unity and hit play. And let's see what happens when we jump on one of these point stars. Absolutely nothing. So points were not added, and the point stars themselves were not triggered. The reason they weren't triggered is you'll notice that the method we used in this case was the onTriggerEnter2D. If we look back at Unity and look at our player, wherever our player is, let's see, player, we'll see that his box collider is not a trigger. And if we look at our point stars, we'll see that their circle colliders are not a trigger. Well, that's not what I want. I want these to be a trigger so that our onTriggerEnter2D method will be invoked. Otherwise, the onTrigger2D method will not be invoked. Now you'll notice I changed the isTrigger of one of our stars. To apply it to all of our stars, I simply have to hit the Apply button on the top right-hand side of our inspector. Now when I go ahead and hit play, we should be able to see that effect. And indeed, we see the effect of the star kind of exploding when we collect it, and we also see that we received points. Now I just want to collect all these stars because I really like that particle effect. Oh, I died. Okay, so let's see some problems. Let's say I collect these two stars and then I die. I now have 20 points. Now I have 0 points. However, those stars are still invisible. So they haven't been recreated. So what I want to do is I want to generalize the concept of respawning objects when the player hits a particular or dies in a particular way before he hit the next checkpoint. So to fix that, I'm going to introduce an interface. The interface I'm going to introduce is iPlayerRespawnListener. So coming back into our code, I'm going to come into code and I'm going to create a new interface called iPlayerRespawnListener. I'm going to remove the namespace definition. And then I'm going to say void onPlayerRespawn in this checkpoint controller, or sorry, player. This method will be invoked by any object that implements this interface when our checkpoint is, or when our player gets respawned in the checkpoint that the object currently is under. Of course, it won't actually do that right now because we haven't written the code that actually looks or inspects certain objects for the iPlayer respawn listener interface. But before we do that, I want to show you guys how the iPlayer respawn listener interface would be used. Then we'll write the code that actually takes advantage of this interface, picks up on all the objects that implement this interface, and then invokes them appropriately. So let's go back into our point star and have it implement iPlayer respawn listener. So I'm going to say comma iPlayer respawn listener, and then I'm going to have ReSharper generate that method stub for me. So as you see, I added an implementation. I said I want to implement this iPlayer respawn listener interface, which requires that I implement this method that was defined on that interface. So the onPlayer respawn in this checkpoint. So what do we want to do when a player respawns in this checkpoint? Well, really, the only thing we really have to do is set GameObject setActive equals true, which will make the star appear again. Now, this logic would have to be a little bit more complex if stars could move, but right now we're assuming that stars do not move. Okay, so now that we have a usage of our iPlayer respawn listener interface, we now actually have to write the code that would be responsible for finding objects that implement that interface and invoking their appropriate methods. The way in which to do that, the simplest way in which to do that, is to come into our level manager, and on the start of our level, I want to find all objects that implement that interface, then I want to assign them to the appropriate checkpoint. I'm going to write a really straightforward, rather inefficient algorithm to do this, and it's inefficient, but it is very straightforward and easy to understand. Its inefficiency, however, will never be noticed because it's only done once, and even if you had, I don't know, 1,000 of these objects that implement iPlayer respawn listener in your scene, you still wouldn't notice any performance impact at all. So in that case, because our performance constraints are not very high, we can take advantage of that fact and write some simple, straightforward code that will go out, it'll find every single iPlayer respawn listener, and it'll assign each one of those to the individual checkpoints that that object appears in. How do we determine which checkpoint an object is in? Well, if we come back into Unity, we could say that, for example, these two stars are owned by level start, in addition to these 3 stars. These are all owned by level start. These stars, these 6 stars, are owned by checkpoint 1, and this 1 star is owned by checkpoint 2. So what we're going to do is we're going to loop through all of the objects that implement iPlayer respawn listener. Then we're going to have an inner loop that loops through our checkpoints backwards. So first, we're going to loop through all the objects that have that interface implemented. So for example, this star. Then we're going to loop through all of the checkpoints backwards. If the x value of the, or if the distance is positive, then that means that that checkpoint should be used for that object. If the distance is negative, that means we should go to the next furthest away checkpoint. So let's come back into Visual Studio and write that out. First of all, how would we go about getting a collection of all objects that implement iPlayer respawn listener? We couldn't do this. This will not work. The reason this will not work is if you look at the decompilation of this method, you'll see that it has a generic type constraint specifying that whatever generic parameter or whatever generic argument that we supply for t has to inherit from UnityEngine.object. Well, obviously, our iPlayer respawn listener does not inherit from UnityEngine.object, in part because you see that it doesn't inherit from anything, and also because an interface can't inherit from a class. So what do we do instead? Well, let's go ahead and say find objects of type mono behavior to find every single mono behavior in the scene. Then we'll use link to filter that by mono behaviors that implement iPlayer respawn listener. Sound good? All right, so
It
So next up, what we're going to do is we're going to say for each var listener in listeners. So now we're looping through all the listeners. Now we have to loop through all of the checkpoints backwards, because remember, our checkpoints are sorted in ascending order of distance to the origin. We want to loop through the checkpoints in descending order in distance from the origin. So what I want to say is for var j. Oh, by the way, the reason we want to do that, I should probably explain that, is if we come back to Unity, let's say we loop forward. So we start at level start, and then we start at checkpoint 1, checkpoint 2, and let's say we're looking at this star right here. Well, this star right here has a positive distance from level start. Therefore, is this star really part of level start? Well, the answer is no, it's not actually. It's part of checkpoint 1. So if instead we loop backwards, we start at checkpoint 2, then go to checkpoint 1, then go to level start, we can find each one of the stars that are owned by that particular checkpoint just by finding the first star that has a positive distance between the two, as opposed to a negative distance between the two. So coming back into Visual Studio, I'm going to say for var I equals checkpoints dot count minus 1. I is greater or equal to 0, I plus plus. Then I'm going to say var distance equals cast to mono behavior listener dot transform dot position dot x minus checkpoints at I dot transform dot position dot x. This will give us a distance value for our this will just give us a distance value between our checkpoint and the object that we're currently looking at. So then I'm going to say if distance is smaller than 0, continue. So if distance is negative, then just keep on looping. Then, if distance is positive, what we want to do is we want to say checkpoints at I dot assign object to checkpoint passing in listener. Finally, the last thing we want to do is break. Because we found the first checkpoint that is within range of this object and we've assigned it, then let's break because we have nothing further to do inside of this loop, and then we'll iterate on this for each loop afterwards. Okay, so you'll notice that we get an error right here on assign objects to checkpoint, and hopefully it'll make a little bit more sense why that's the case. If I look at this method signature, you'll see that it's empty. The reason is when we stubbed out our checkpoint class, we didn't write our iPlayer respawn listener and was therefore unable to complete the parameter list for our method stub. But now that we do have an iPlayer respawn listener type available to us, we can add that proper parameter to the assign objects to checkpoint method. All right, so that's that code. Let's jump into our checkpoints because we have some interesting things to do inside of this particular method or this particular mono behavior. First of all, to make the code compile, we have to accept an iPlayer respawn listener. Now, what do we want to do here? Well, what we really want to do is we really want to add this to a collection that's owned by checkpoint so that we can loop over every single object that's assigned to this checkpoint and inform it when the player needs to be respawned. So let's go ahead and create a private list of iPlayer checkpoint iPlayer respawn listener, and we'll call this underscore listeners. Now, of course, this will require that we bring in system collections generic at the top. Now that we've done that, we need to instantiate listeners. But where should we instantiate listeners? I actually kind of misspoke when I said that we need a start method in checkpoint because we actually need an awake method in checkpoint. And then we'll say listeners equals new list of iPlayer respawn listener. People might be going, why don't I just do listeners equals new instead of creating an awake method and initializing it there? Well, the reason is I really don't like field initializers. I find field initializers to be very ugly, and I also find them to cause a lot of problems, both in the order that they're executed in, as well as the ability to override those values depending on, for example, which constructor you might be using, in addition to them being executable code inside what should be just a definition of a field. I really, really don't like the idea of executable code being assigned to anything inside of a field, and an instantiation of a list is executable code. That just doesn't gel well with me. Anybody who's watched any of my other Unity videos will know that I just don't do field initializers. The only exception I make to that is when I'm using a field initializer to tell Unity to have a default value for a public field. But in this case, this is a private field that isn't exposed to Unity. Therefore, I will rather instantiate it in my awake method rather than as a field initializer. Anyway, now that I have a collection of listeners, what I'm going to do is I'm going to come down here to my assign object to checkpoint method, and I'm going to say listeners.add listener, which will just add it to that collection. Alrighty, there's one more thing that we have to do, and that is we need to actually invoke the method on this interface to inform the player, or to inform these objects that they need to be replaced. So on our spawn player method, I'm going to say for each var listener in listeners, listener dot on player respawn in this checkpoint, passing in this as our checkpoint parameter and passing in player as our player parameter. Again, this code will result in any mono behavior that implements iPlayer respawn listener to be notified when the player has been respawned on the checkpoint that the player has died at. Let's go ahead and see if that works. So remember, we've implemented the onPlayer respawn in this checkpoint to say GameObject.setActive on our point star. So let's jump into Unity and see what happens when we hit play. We'll collect these 2 stars, and then we'll die. And they don't reappear for some reason. Let's go ahead and debug this. Okay, so jumping back into our code, the easiest way to debug this would probably be to look at our level manager. No, look at our checkpoint and see if assign object to checkpoint was ever invoked. So I'm going to say debug.log hello world. And this is going to invoke this if any listener ever gets assigned to a checkpoint. And we see that to not be the case. So therefore we've narrowed the problem down to the assign object to checkpoint method never being invoked inside of the level manager class. So why wouldn't that be the case? Well, let's go ahead and notice right here that we made a very, very terrible mistake on our loop. We said I equals checkpoints.count minus 1, I is greater or equal to 0, I plus plus. I don't even know why this isn't. Oh, wow.
What is it?
Okay, so people who've been watching this video have probably been severely confused about something. We haven't, 2 mistakes. First of all, I++ should be I minus minus. We're looping through this loop backwards. Second of all, why in the world did I add this code to the update method of my level manager? That means this code gets invoked every single frame, which is not what I wanted. The reason why we didn't get an error or anything was because this code had never been executed. This code had never been executed because we never hit a checkpoint. So what we're going to do is we're going to cut this out, and we're going to paste this into our start method. We're going to place this into our start method before we invoke the spawn player. Wow. I know how to program, seriously, guys. Trust me. Okay, so yeah, besides that massive...
Well, you wrote it right.
Yeah, and to be fair, at least people saw, the steps for finding the problem. I just happened to notice the problem, just arbitrarily noticing it was in the wrong method. Okay, let's come back into Unity and let's redeem myself. Coming into here, collecting these 2 stars. Let's go ahead and die. When we die, those 2 stars reappear. Our points gets reset to 0. Let's hit a checkpoint and then die again. Notice how these stars did not reappear. See, this star would reappear because I'm within that checkpoint. See, watch, those 2 stars reappear. But once I hit another checkpoint like what I just did and I die, notice how the only star that reappears is the one that was part of this checkpoint, which is exactly the behavior I want. Otherwise, the player would be able to sit there and die and continuously get points over and over and over again, and that wouldn't be... Or no, he wouldn't be able to retrieve points after the fact. Anyway, yeah, I think that pretty much wraps up our points. Or not our points, but, well, mostly our point system is done, but our point adder in particular. There's a couple other fun bits of code that we're going to write here shortly that'll give the interface a little bit of a better feel to it, where we'll add some floating text whenever we receive a point. But yeah, I think that
Sounds like fun.
yep, this pretty much wraps up this video, and we'll see you guys in the next one.